This is EGME-331 solid mechanics. In this video, we'll review thin-walled pressure vessels. So what are thin-walled pressure vessels? They are one of the most typical applications of plane stress. A thin-walled pressure vessel is one in which the skin of the vessel has a thickness that's much smaller than the overall size of the vessel, and the vessel is subjected to an internal pressure that is much greater than the exterior air pressure. For classification purpose, a thin-walled pressure vessel have an inner radius of R that's 10 times, at least 10 times more than the thickness. That means R over T, where R is the radius and T is the thickness, would be greater than 10. When a thin-walled pressure vessel is subject to stress, there can be multiple stresses that need to be considered. The first among them is the circumferential or the hoop stress, which is nothing but the stress distribution with a rotational symmetry. That is, it remains unchanged even if the stressed object is rotated about a fixed axis. And then we have the longitudinal stress, which is a stress along the axis of the body. So we have two stresses that need to be considered. The first one is the hoop stress. The other one is the longitudinal stress. Now we have different types of pressure vessels. The most popular among them are the cylindrical and the spherical pressure vessels. A pressure vessel that is cylindrical in shape has a hoop stress and a longitudinal stress. The hoop stress, however, is normally always at least 2 times greater than the longitudinal stress. This means if you consider structures like hoses or cylindrical type vessels, it will be splitting on the side walls rather than being pulled apart like being under an axial load. So it will tear on the side walls rather than along the length. So that's something unique with the thin-walled pressure vessels.